So let's review how to subtract integers. If you recall, we used the number line the other day, and we looked for patterns in what would happen when we subtracted numbers. We started out with simple problems like 8 minus 3, then we went to 8 minus negative 3, and we found out that subtraction can be written as addition as long as we add the opposite of the number being subtracted. So we keep the first number the same, change subtraction to addition, and we then use the opposite of the number being subtracted. And here we have it represented in algebraic form. A minus b is the same as a plus the opposite of b. I also want to tell you that we can refer to the opposite as the additive inverse. So why would we want to change subtraction to addition, and how is this done? Well, we talked about how it's done, but the reason why we want to use addition is because then we can use the commutative and associative properties to simplify problems, to make them much easier to get the answer. In this problem, by changing to all additions, I can move the negatives together, move the positives together, and add the same signs. So to continue our review, let's get a piece of notebook paper and a pencil. At the top of the paper, write the following information, including your name, date, and math period. Let's give your paper a hot dog fold. So fold it over, crease it down the middle, and then open it back up so you're ready to take some notes. So let's start on the left-hand side with example number 1. So our first example starts with 104. Then we're going to subtract 8 and then subtract 104 from that. So what our plan is to change each subtraction into an addition using the opposite. And the reason we want to do that is so we can move the numbers around to make the simplification of the problem a lot easier. So if you notice, there are 2 negatives, but there's also 2 opposites, 104 and negative 104. So I'm going to move those next to each other. And of course that gives you 0 plus negative 8. So the final answer is just a negative 8. In the next problem, we only have one subtraction, but if we can change that into an addition, which I have shown here, we can then move all the negatives together, all the same signs, and we can end up getting a negative 34 by adding those negatives together. Then when you add on 14 to that, we have to subtract their absolute values, and we end up with a negative 20. In example number 3, we're going to change this problem into all addition. We're then going to add all the negatives together. And then we're going to add 70 to that. And by using the rules for addition, we end up with a positive 9. In the final example, number 4, notice we have a multiplication. So we're going to do that first. Then we're going to take each of the other numbers and the signs and bring them down. And we're going to change the subtract 50 into adding negative 50. And then we're just going to add up all the numbers because they all have the same sign. Just add their absolute values and keep the negative sign with it. So you get a negative 64. So there you have it. 4 more examples of how to change subtractions to additions, and then using the commutative and associative properties to simplify them.